and today I would like to say you something about GeoPython. So how to save the world using Python. And I'm Małgorzata Niewiem. And yes, it is very funny surname. Yes, I have many funny situation with my last name, but I'm a Python developer now at a small company from Krakow. It is a startup named Sati, and I'm also PhD student at Krakow and AGH University of Science and Technology. And on the beginning of my presentation, I apologize for any mistake in my presentation, but last Friday I moved from Poland to Switzerland, and after today I came back here to Poland, so I spent so much time at airport, so I'm so sorry for any problems. Okay. So, on the beginning, I would like to talk to you what is the Geo. When I have to say something about GeoPython, I must to tell you something about Geo. So, what is Geo? Geo includes so many definitions, so many terms, and for example, there is a geographic information system. Maybe somebody know GIS. There is also the cartography, remote sensing, geography, photogrammetry. It is also a global navigation system. I think that most of you use GPS, which is the American system of navigation system. I think everybody has in a mobile phone, but it's also other navigation system. For example, GLONASS, which is a Russian system. It is also Galileo, which is the European navigation system, and it is the Compass, which is also named Beidou, and it's a Chinese navigation satellite system. You can check in the internet if you want. Okay, so if we think about Geo, we think about mapping. So when we think about mapping, we had to think about position, because Geo means that we have position of object, event, people, and other thing, but in position in the space. So to describe the position, we use two ways. The first way is the absolute ways. And absolute way means that we have some coordinate system. And maybe you know in the Google Earth, Google Maps, there is the coordinate system. It's the famous coordinate system, UTM. It's also American system. And we have some number about our position in the space. And the other way to describe our position is a relative way. And we use some name, for example, name of city to describe our position. We use some information where we are now. Maybe not we, but also the other objects and event in space. So when we know something about position, we must also know something about type of data. So in the Geo, we use two types of data, the same as in computer graphics. So we have the raster and vector. The difference is the same as you know. But in vector, we have three basic types. We have points, line, and polygon. And the difference between these types depends on what we want to describe, on what we want to storage. So maybe some example. When we want to mark some object in the map, we must know which type of object we can use, so point, line, or polygon. And if will be a building, we can we only decide which type of data we use. So, for example, if we only want to check this building on the map, but with no other information, only the building and the number of building, we use point. But if we want to add some more information about length of this building, we use line. But if we want to have more information than line, for example, the size of building, we use polygon because we must to mark the edge of this building on the map. So which type of that data we use, it depends on situation, on object, and what we want to describe. And the raster, in the raster we have pixels, so it's not surprised there. And here is the example of this data. On the left, there is the raster data. There is satellite imagery from Sentinel mission. About Sentinel, about European Space Agency, I tell you later. And on the right, there is the vector data. And here is the vector map of Poland from official head office of geodesy in Poland. And now we know something about geo, what is the localization, what is the type of data. So I would like to tell you something about how to get this data. Because somebody asked me, okay, maybe you have the access to this data, but I'm lack of this knowledge, so maybe could you help me? Yes, of course. These data are for free. Of course, not all of this data because there is so many commercial data. But if you want to use some geodata, you can. For example, if you want to have some access to satellite imagery, you can. There is the Sentinel mission about what I told in the previous slide. And satellite mission is launched by European Space Agency, and it is for free for everybody. If you want to use, you must go to this website, which is on the slide, and only you can create an account, but it's for free, and you can download data. And I show you also how to analyze this data later. But now you know that you can download this data for free and everybody can use. And in the Sentinel mission we have 4 satellites. For example, the first is the Sentinel-1. It is the radar mission. The Sentinel-2 is the satellite for land monitoring. There is also another satellite for air quality monitoring, which is so important now. And the another source of free data is Landsat. It is the American mission of satellite. Here is also the website from where you can download this data. And Landsat mission is the longest running mission of satellite imagery. The first satellite, it was Landsat-1, was launched I think 1972, and the last Landsat 8 was launched 5 years ago. And so there is so many data on this server if you want to download it. And here is the example of vector data, because the Landsat and Sentinel was the raster data. But if you want to have some vector data, you can use OpenStreetMap. It is very familiar as Google Maps, but it is open source. And everybody can edit this data, and everybody can download this data. There is so API for the developer if you want to use OpenStreetMap. Okay, so now something about Python. In the Geo, Python is the most important, most used language. But why? Because I think it's easy to learn, and so many applications in Geo are developed using Python. The code is readable. There is so many libraries for Python. For example, sometimes the people from Geo use OpenCV because it's very similar to analyze the image from satellite, and very similar to, for example, image from medicine. And here is some list of libraries for Geo, but it's only very short list because now I think there is about 100 libraries for Geo. So here is only the famous library, very important, and I only show you the one which I use in my project. And this library is GDAL, Geospatial Data Abstraction Library. And GDAL also has another library because on the beginning GDAL was a library for the raster manipulation, but in the same time these same developers develop the library OGR for vector manipulation, and after when they finished those projects, they merge in one library, which is GDAL. So we have GDAL for raster and for vector data. It is of course open source, but yes, it is only one problem with this library because it is not Pythonese library. So if you are beginner in Python, maybe not Python, but if you are beginner developer, it is difficult because it is only wrapper from C and C++. So on the beginning it is difficult, but I like this library and I used it very often. And here is some example of how to read the raster. And as you see, there is rather C++ way of reading, not Python. So if you open the image, you can see how is the size of this image. Oh, sorry. I think there is difficult to see this code. I'm so sorry. Okay, so after presentation, I sent my presentation. If you want to see, it will be available. And you can open your raster. You can see the size of this image, and also you can see the bands of image and some statistic of every band, for example, some minimum and maximum value. And I tell you that in the image there is bands. Bands means that we have more than 3 bands, not only RGB, that is in the standard image, but also the more bands. But why? Because in the satellite imagery we have so many bands because it is wavelength and we have visible light. And for example, in the Sentinel-2 satellite, which I tell you, there is 13 bands, I think, and more of them is the near-infrared bands. Okay, after opening the image, you can also get some information about projection. So projection means where is your image in the map. So we have some information about top left corner. And you can also see the information about pixel size. It is very, very important information. Why? Because pixel size means the size of the smallest object on the map. Of course, when the image is displayed at full resolution. So it's important to have information about pixel size because Sentinel, for example, Sentinel-2 have pixel size about 10 meters and Landsat have only 20 meters, so it is difference between this image, and we know that in Sentinel we see more than in the Landsat satellite. Okay, so now is some example of how to use this data, these libraries, and this all information which I describe here. And for example, for agriculture, if you want to check crop condition, detect land cover, and everything for save money and time to some efficiency and precision farming, and to help other people to save the world. And here is some example. It is very, very basic index which we can calculate in Geo. It is NDVI, and it is the difference between near infrared and red bands. And on the left, there is the photo before the image before NDVI, and on the right there is after NDVI, and it is Krakow. So the green means that there is good condition, a good crop condition, good vegetation. And red means that there is some problem, but it is the city, so it's not surprising that we have some red area here. And how to use this information, for example, of NDVI index. It is the project which I was a Python developer. Project called AgroEye, and it was funded by European Space Agency. And what we do in this project. Maybe somebody knows about something about direct payments for farmers. So farmers, if have some ground, some fields, can get some money from European Union for farming. But it is some difficult with this. Somebody must check that farmers is farming and everything is illegal in this field. So now our government check this state of farm in this way that some people are going in the field and check what is going here. But it's very expensive, and so many time these people spend to going. So we wanted to help our government to check this situation, and we use Sentinel data, some algorithm of classification, and we checked what was going in this field, because the farmer must fulfill some requirements, and European Union has some list of this rule which they must fulfill. And for example, the basic rules is about cutting off the grass once a year. So we check that the field was cutting once a year. And here is example that we check that farmers not build something in this field, because it is field for farming, not for building. Yes, so we check that some people build something illegal. And another project, which I was a team member, was SatAgro. And in the previous project, we verified the farmers. Now we can help the farmers how to increase the farming. So we have some application which is called SatAgro, and farmers can buy some access to this application and check some information about this own field. For example, about some crop condition, about weather condition, about disease and disaster. And after agriculture, the another important thing how to save the world is the natural disaster. Using the satellite imagery and other data, geodata, the vector data also, we can also prevent some, not prevent, but get some information which help people in natural disaster. For example, to monitor some air quality, monitor active volcans, ground deformation. And here is the example from my last project. It is about ground deformation. In the south of Poland, we have problem with ground deformation because there is the mining activity. So people have problem with ground deformation, and using the another type of satellite imagery, or Sentinel-1, which is the radar imagery, we can get some information about ground deformation. Example, here is some city from south of Poland, and the red means that it was very big ground deformation and people can be can protect their properties, and because they have some information about occurrence and scale of this deformation. Okay, and there's the one example. Using the satellite imagery, you can also check another thing. For example, where is your package from AliExpress? It is a QuickBird satellite, which is commercial, so it is not for free, and it's very expensive. So maybe you not want to check this information, but if you want to another information which is very important for you, I think you buy this imagery. And this satellite have pixel size less than 1 meter. So you can see that we see shape of the on this imagery. And the last is the, you can see also royal wedding, and is the World View 2 satellite, which is also the commercial satellite. And okay, thank you very much for listening. And here is my email if somebody want to write to me and any question.
So I noticed that you showed examples about crops. So I was wondering, how often does the imagery from the satellites refresh?
Okay, I don't say about this, but this free satellite, Sentinel-2 for crop condition, is for every 6 days. But there is so many commercial satellites which is for 1 day. And
so for example, the free data is not very useful, for example, for like monitoring for disasters or something like that, because the lag for 6 days is like too high, right?
Yes and no, because some natural disasters are not so dynamically.
Yeah, like the ground.
Yes, the ground deformation, landslides. So, yes and not. No.
Thank you.
Next questions?
So a bit similar question, but regarding OpenStreetMaps. So do you see where it cannot be applicable and you would have to go with some commercial solution instead of? So the biggest limitation that you notice with OpenStreetMaps, maybe this.
Okay, is also the question about when we should use the commercial and open source. So it's difficult to say about limitation. One limitation which I know is that this data from OpenStreetMap are editable by people. So there is so many mistakes, so are not sometimes correct. So you can verify this data, but it's yes, very similar. Yes, as Wiki project. Yes.
Any other questions?
So, is there any other free imagery where the pixel size is like less than 5 meters?
No, because it is a business. If you have a satellite which is commercial, you have money, you don't want this data will be for free. So the European Space Agency has the better pixel resolution in the world now for free.
Any other questions? No. Thank you, Małgosia, for your presentation.